Today we are starting the numerical problems of force and motion, and this is part 1. Okay, in this chapter what we are going to calculate: gravitation, gravity, acceleration due to gravity, and weight. These four are the important terms which are involved in the numerical problem. And before entering into the numerical problem, we must have clear idea about the equations which we use to solve the numerical problem. This is the first equation: F equal to g m1 m2 by d square. If we have given two bodies, then the mass of first body can be symbolized as m1 and mass of second body can be symbolized as m2, and distance between them should be symbolized by d. And if you are asked to calculate the gravitational force between these two, that is represented by F. This type of numerical problem is solved by using this equation or this formula, where F equal to g m1 m2 by d square. M1 and m2 and d may be given, and F you have to calculate, or out of these four any three are if given, fourth can be calculated. But this capital G, we know the value of capital G, it is 6.67 into 10 to the power minus 11 Newton meter square by kg square. Now second equation, look at this: F equal to capital G mm by r square. This is same as the first, but a little difference is, if we have given a huge heavenly body, let's say Earth, and a body is lying on a surface, the distance between them would be d, but it is the radius of the Earth. Mass of the Earth is capital M, and mass of the body lying on a surface is small m, and the distance between them is capital R. Okay, this equation and this equation, these two are basically same equation. And if you are told to calculate the force of attraction of this heavenly body acting on this body, then you can represent this by F, and we will calculate F. If we consider this as the Earth, then the force of attraction of the Earth acting on this body is considered as the weight of the body, which can also be denoted by W. Okay, now let's have another equation. Third equation: G equal to capital G capital M by r square. This equation is used to calculate acceleration due to gravity. Let's say this is Earth and its mass is capital M and radius is denoted by capital R, and if we have to calculate the acceleration due to gravity on the surface of the Earth or near to the surface of the Earth at this place, then the symbol is small g. This can be calculated by using this equation, because capital G we know, mass of the Earth is if given, radius is also given, then acceleration due to gravity can be calculated, or out of these three, if two are given, third can be calculated. This is third equation. Okay, let's have fourth one: G dash equal to G m by r plus s whole square. This equation is also used to calculate the acceleration due to gravity, not on the surface of the Earth, at certain height. Let's say this is the mass of the Earth and this is the radius of the Earth, and we are going to calculate the acceleration produced on a body at this height. This height is denoted by h, and acceleration at this height can be considered as g dash. We can use this equation to get g dash at this height. Okay, now let's have fifth one also: W equal to mg. Weight of the body equal to product of its mass and acceleration due to gravity. If we have Earth and a body is lying on its surface, its mass is small m, then the force of attraction of the Earth acting on this body is the weight of this body, and this force acts towards the center of the Earth. Weight of the body is the product of its mass and acceleration due to gravity. One by one I want to use each of them. Let's have one numerical problem. Two objects are at a distance of 400 meters and the gravitational force between them is 4.16875 into 10 to the power 4 Newton. If mass of one of them is 2 into 10 to the power 7 kg, calculate the mass of another. Now we have to write the given first. This is the distance between them is given, which is denoted by small d, and this is the gravitational force denoted by F, and this is the mass of first body can be denoted by m1. That's why I can write distance 400 meter, gravitation F is 4.16875 into 10 to the power 4, and Another information, mass of the body m1, it is 2 into 10 power 7 kilogram. And we are going to calculate the mass of second body. Here something is missing, that is capital G, and capital G we can take ourselves. Okay, how to solve the numerical problem? Which equation is useful here among these five which I told you just before this? Which one? First one is suitable for this. Why? Because f, g, m1, m2, d. G we know, that's why we have to source for f, m1, m2, d. Here it is f, here m1, m2, d. All are present. G we can take ourselves. That's why first equation we are using. So we can write we have, this is the equation which we are going to use. Now I want to put the value. In place of f, its value is given here, and in place of g, its value is written here, and this is m1 and m2 remains same, and distance between them is 400, and that's why 400 is square. Now what we are going to do, this 400 is square, we can take it to the left hand side this way. 400 is square, and we have right hand side this 6.67 is multiplied with 2, and 10 power minus 11 into 10 power 7, same base power can be added or subtracted. Minus 11 plus 7 becomes minus 4. And another step, we have to take this m2 in one of the side because we are calculating m2. Now this quantity should be taken to the denominator. Here I am taking that. Okay, now what we are going to do, we have to divide this with this. Number divides the number, isn't it? Number interacts with number, and power of 10 interacts with power of 10. 10 to the power 4 is present in numerator, and in denominator we have minus 4. If the same is taken to numerator, it becomes 10 to the power 4. And 400 square means 4 4s are 16, and 0 0 how many? We can write 4 0 because 2 0 here and is square. Okay, now next step, we have to convert this number into power of 10. This is a very big number. So how can we do this? If point is at this place, it has to be taken to this place. It means how many digit it is shifted to left hand side? 5 digit. That's why I can write 1.6 and multiplied by 10 to the power 5. Since point is shifted 5 digits left hand side, that's why it must be multiplied with 10 to the power positive 5. If it was shifted to right hand side 5 digit, then 10 to the power minus 5. Okay, all the numbers are same. 10 to the power 4 into 10 to the power 4 means 10 to the power 8. Let's go to another step. m2 equal to, if this number is multiplied by 1.6, we'll have 0.5, and 10 to the power 8 and 10 to the power 5 remains same. Now we are not taking point number. This point is if shifted to right hand side, one digit right hand side, then we have to multiply this 5 with 10 to the power minus 1 this way. And 10 to the power 8 and 10 to the power 5 remains same. 8 plus 5 13. 13 minus 1 becomes 12. That's why m2 is equal to 5 into 10 to the power 12. And we can write, therefore mass of second object is 5 into 10 to the power 12 kilogram. Okay, let's have another numerical problem. A man of 100 kg stands on the surface of the earth. Very interesting. A man is standing on the surface of the earth, which has 6 into 10 to the power 24 kg mass. Earth's mass is given 6 into 10 to the power 24 kg. If the radius of the earth is 6400 kilometer, we don't have to use this kilometer because we are using SI system. That's why we have to convert this into meter. 6400 kilometer, then calculate the gravitational force between them. What are given, I am writing the same. Here 100 kg mass of the man is given. In comparison with the earth's mass, the mass of the person is very less. That's why it is denoted by small m, and mass of the earth can be denoted by capital M. We can write this way: mass of earth capital M is equal to this, mass of man small m equal to 100 kg. Now all the information, radius is also given. Radius 6400 kilometer if multiplied by 1000, then we'll have this number. Now we have to shift point from this position to this position. 6.4. How many digit point is shifted to left hand side? 6 digit. That's why we have to multiply this 6.4 with 10 to the power positive 6. If it was shifted to right hand side 6 digit, then we'll be multiply the same with 10 to the power minus 6, but here positive 6. Okay, now next step, gravitational constant which is not given in the numerical problem, we can take ourselves 6.67 into 10 power minus 11 Newton meter square by kg square. Now how to solve this numerical problem? Among these equation, which one is suitable? Now we have to see this. Here we have capital M, small m, r, and what? F. G is also present. Capital M, small m, r, and f. It is present in second equation. So we are using second equation. So we have the second equation I am writing, f equal to g, capital M, small m by r square. Now I have to put the value of each of the physical quantity. This capital G is written here and capital M here. It is 6 into 10 to the power 24 and small m is 100 and radius is 6.4 into 10 to the power 6 whole square. Now next 6.67 if multiplied by 6 then 40.02 and 10 to the power minus 11 into 10 power 24 means 10 power minus 11 plus 24 and this 100 can be written as 10 square. Now in denominator 6.4 into 6.4 because here we have square, that's why 40.96 10 power 6 square means I am writing 10 power 6 twice. Now next step 0.97705. How it came? Dividing 40.02 by 40.96 we will get this number and 10 to the power 24 minus 11 becomes 13 and this 10 to the power 2 is added to 13 in numerator. In denominator only 10 to the power 6 into 10 to the power 6 is left which can be written as 10 to the power 12. Now next step 0.97705 into 10 to the power 13 plus 2 15. When 10 to the power 12 when goes up we can write minus 12. Now what is the result? 0.97705 into 10 to the power 3. 10 to the power 3 means 1000. If this 1000 multiplies this, then we'll get this 977.05 and this is our final result. I mean to say the weight of that man or the gravitational force of the earth acting on that man is 977.05 Newton. That's why we can write one sentence for this. Therefore, weight of 100 kg mass on the surface of the earth is 977.05 Newton. Okay, let's have another numerical. Calculate the mass of the earth considering it as a sphere of radius 6.67 into 10 to the power 6 meter. Very interesting. Only one information is given. Can we calculate the mass of the earth? Only radius is given. Let's have the equation. The first equation we cannot use, only radius is given. In second equation we have radius and mass of the earth is asked but small m is missing in the numerical. That's why second equation cannot be used. Now let's have third equation. Look at this small g. We can put the value 9.8 and capital G we can take the value 6.67 into 10 to the power minus 11. Now radius is given here, then capital M can be calculated. Mass of the earth can be calculated. If mass of the earth was given, then radius can also be calculated. So this third equation is suitable. So I am writing here, we know that acceleration due to gravity is 9.8 meter per second square and gravitational constant capital G is 6.67 into 10 to the power minus 11 Newton meter square by kg square and radius of the earth which is given 6.67 into 10 to the power 6 meter and mass of the earth we are going to calculate. Now we have, okay, now I am taking value of each of them. G, small g 9.8 meter per second square, capital G 6.67 into 10 to the power minus 11 Newton meter square by kg square and M remains same. Radius is square, radius is 6.67 into 10 to the power 6 meter whole square. At this time I am taking units of all the physical quantity. I want to show you how do we get result with correct unit. But remember one point, if you do not feel comfortable, then don't write units in the process. It is not a compulsory part. But you must write the unit at the beginning in the given and at the end in the answer. But in the process, if you don't want, don't write unit. Okay. Now, in another step, what I did, look at this. The 6.67 into 10 power 6 meter whole square can be written twice this way. 6.67 and 6.67 are present in numerator also, denominator also. We can cancel them. Yeah, one of the 6.67 is cancelled, which is present in numerator and denominator, but still we have 6.67 in the denominator. Look at this, 10 to the power minus 11 is left. There is meter square in numerator and there is meter in denominator also, two places, so we can cancel this meter square, and kg square is left. Capital M remains same, and in denominator we have 6.67 into 10 to the power what? 6 plus 6, 12. Now next step, I want to write the expanded form of Newton, that is kg meter per second square. Now M is taken to one side and this value is taken to numerator, this is taken to denominator. Now next step, we can write this way. Now 9.8 multiplied by 6.67 gives 65.366, and look at this, meter per second square cancel, and kg square goes up and kg remains in the denominator. One of the kilogram cancel each other, and then finally we have 65.366 into 10 power 23 kg. But point is after 2 digit, that's why I want to take this point to this place after 1 digit. So I can take this to 1 digit this way. If it is shifted to 1 digit left hand side, then it must be multiplied by 10 to the power 1, and 10 to the power 1 into 10 to the power 23 becomes 10 to the power 24. And look at this number, if we are using just 2 digit after decimal point, after 5 there is 3, but after 3 third digit is 6. If third digit is 5 or more than 5, 1 can be added to 3, and the same is done here. 6.54 into 10 to the power what? 24 kilogram. This is our final answer. So I can write, therefore mass of earth is 6.54 into 10 power 24 kilogram. Okay, now I want to stop. I'll continue in next class. Thank you.